Okay, today we'll look at Packet 1 Beginning Algebra, which is just some pre-algebra review. Notice we got some vocabulary here, some basic vocabulary that I'm sure a lot of you know. Knowing what a variable is, an unknown quantity, usually described by a letter, constant, a number that doesn't change, algebraic expression, basically just numbers, letters, and math operations. Something like this. How you read this is 3 times some number x plus 2. Also knowing what an equation is, setting two expressions equal to each other, and essentially solving it is what your goal is. So something like this would be an equation, and you would definitely try to figure out what the unknown is. Another definition with notation, absolute value. Notice the notation of two vertical lines, and all that just means is positive distance from 0. And of course, what most people know as PEMDAS, order of operations, knowing to get rid of parentheses, exponents, multiplication and division from left to right, and then addition and subtraction from left to right. So those are some quick basic things to remember. Let's look at some examples. So these two examples, notice they are algebraic expressions, right? When you read this, -2 times some number x plus 8, where x is equal to -4. That just means x is -4, so we can substitute that in for the value x. And use order of operations to evaluate this or simplify it. So -2 times -4, 8 plus 8, which is 16. And done. This example, very similar, right? Another expression, 3x squared plus 2 times y minus 5, where x is -4 and y is 5. Plug those values in and evaluate the expression, like so. So let's just evaluate order of operations, as we got to get rid of exponents. -4 squared. So 3 times 16 plus 2 times 5, which is 10, minus 5. And then just following order of operations still. Multiplication, 3 times 16 is 48, plus 10 minus 5. And then we're just left with addition, subtraction, which we do from left to right. 48 plus 10, 58 minus 5, which is 53, and done. So just looking at some more examples of expressions and evaluating them. X plus 10, where x is 7, just 7 plus 10, 17. Number 2, 5r plus 52 over 3 times r, where r is 4. So just plugging the number in, 5 times 4 plus 52 over 3 times 4. So we do have this fraction where we got stuff on the top, stuff on the bottom. Notice I put parentheses around the top and the bottom. That's mainly just as a highlighter to say do that, and then simplify. So on the top, 5 times 4, 20 plus 52 divided by 3 times 4, which is 12. Again, just highlighting the top to show that I'm looking at 20 plus 52, which is 72, divided by 12, which is, of course, 6. Number 3, again, just another algebraic expression. 3 times x plus y, where x is 5 plus y, which is 6. Then you're just using order of operations to evaluate. 5 plus 6 is 11. So we have 3 times 11, which is 33. And done. Some more examples of looking at expressions or equations, translating expressions and equations, recognizing key words that mean math. So here are a couple of examples. The product of a number m5 is 30. If you translate that, remembering product means multiplication of a number m5, so the product of a number m5, 5 times a number is, which is equals 30, and there we go. And when we translate it, we can easily see that this is an example of an equation. This example, the difference between twice a number and 3, very similar example in that you are just reading the sentence and pulling out key words that mean math. Difference means subtraction, so difference between twice a number and 3. So twice a number means 2 times some number, and the difference of twice a number and 3 is going to be what you get when you subtract them, and that is an expression. Do notice the difference between this example and this example. This is an equation. We solve the equation. I mean, if you think about it, you can totally solve this in your head. 5 times what number will give you 30? I'm sure most of you, all of you, would know that that is 6. Here, this is an expression where we don't know what n is, and it can be anything. We would evaluate it. We solve equations, we evaluate or simplify expressions. Some more examples. The quotient of 12 and a number is 4. So, translating it, something a lot of students don't recognize, but you definitely want to know. When you see quotient, that means division. So the quotient of 12 and a number, the quotient of 12 and a number is 4. So that's an example of an equation. And again, knowing that this is an equation, if I were to tell you to figure it out, you know that 12 divided by some number will be 4, which means that number must be 3. 8 less than a number. Now, a very common mistake students will make, and I'm just going to tell you right now, is a lot of students will write 8 minus a number, but that does not say 8 less than a number. 8 less than something means you are taking 8 away from that number. 8 less minus 8 than a number. And that is an example of an expression. Just translating expressions or equations. The sum of a number and 6. Sum means addition. So the sum of a number and 6, right there. Or you can write, since addition is commutative, associative, 6 plus a number, either or. And this is an example of an expression. You don't solve expressions. You don't know what n is, so you cannot solve it. But if I told you n was 7, you could totally evaluate it. Number 2, 5 times a number decreased by 3. 5 times a number decreased, meaning subtraction, by 3. And there it is. 5 times a number decreased by 3. And this is an example of an expression. 3, the quotient of a number and 8 is 12. So the quotient, division of a number and 8, so a number and 8 is 12. The quotient of a number and 8 is 12, and that is definitely an equation. The product of a number and 6 increased by 3 is 33. Product multiplication, so product of 6 and a number, increased by 3 is 33, which is a wonderful equation that you would solve. Okay, let's review fractions. First, we will review simplifying fractions. The basic way to simplify fractions is to, first, factor the numerator and denominator completely, and second, cancel out common divisors. So let's do these examples. Notice with this example, when we factor the numerator and denominator, there are no common divisors. So we are pretty much done. Now let's look at multiplying and dividing fractions. Remember when multiplying fractions, you multiply numerators and denominators together then simplify the fractions as much as possible. Now we will do the same process for the next couple of examples. Let's review dividing fractions now. First, rewrite division as multiplication. And second, now we just multiply fractions like the previous examples. Here are just some other examples of reviewing fractions. The first example is converting a mixed number into an improper fraction. The process is just to multiply the denominator with the whole number, then add the remainder, and your result stays on the numerator. Converting improper fractions to mixed numbers, you just divide as normal and write your remainder as a fraction. This example is just remembering how to break down a number completely, aka prime factorization. Now let's review adding and subtracting fractions. First, you should find the lowest common denominator, the LCD. In this case, the LCD would be the smallest number that 6 and 4 divide into, which is 12. So we multiply the fraction on the right by 3 to the top and bottom, and we multiply the fraction on the left by 2 to the top and bottom. Now we have equivalent fractions with the same denominators, so we can add the numerators. And if possible, 3, we simplify. Here, the fraction is fully simplified. We can rewrite the improper fraction as a mixed number if we want to. The next example is very similar, but it's subtracting two fractions instead. So first, find the lowest common divisor. Second, add or subtract the numerators. And third, simplify if possible. Here are some practice problems.
I think that this is just going to be a process for me to really be able to be comfortable being intimate and feeling like a romantic partner versus just, this friend. Oh, you do?
When operating on fractions, it is very important to read and understand what you are looking at. For example, these next two examples involve multiplying or dividing fractions. And if you remember the process for those operations, it's pretty simple.
I thought that it would just be 2 of them, maybe 3 times. And there were about 8 of them. Yeah, that's pretty cool. And I'm like, here we go, this one panic attack. Oh my god. And in my head, I'm thinking, this is what you want, Jessica, this is what you want, right now. And smile, you're there's also good doing tricks and swimming with us. To be honest, I do treat him like he's one of my buddies, but that straight to Central Park and took me on a carriage ride, and then had a dinner plan to decide this restaurant. Did you hear what I said? I heard some feedback. I feel like you have like a dog. That's exactly why I played. Yes, because you want to learn how to. Oh, see? That was my most important take for you. And how about?
For Davina, I'm worried that she tends to look for red flags. Davina's always had to take care of herself emotionally and never really had anyone that she really depended on. Sean really has what Davina most needs in a partner is a strong and caring person.
That was me. It wasn't me. That was you. Like, you were opening that up. Oh, I'm so sorry that it wasn't. I'm not going to overanalyze it to death because I want to enjoy this. And actually, each day has been more romantic than I ever did at the beginning.
See? There's a romance.
They say flip the script, then you'll be there for a reader, because it's full of fine print. Documents are so common, and really isn't. At Simple Mobile, we say script the flip. Truly unlimited high-speed data, talk and text, with nationwide coverage on a blazing fast 4G LTE network for just $45 a month.
The world of fashion has changed. The most in-demand models today are the famous last name.
Drug was very dangerous when I was small.
My whole life I've been You're never going to be your mom.
I haven't really been there like you want me to be there.
I try to love you.
Support the Feeding America nationwide network of food banks to help provide meals to those in need. Join us at feedingamerica.org.
Now let's look at the properties of arithmetic. First, we'll look at the commutative property of addition and multiplication.
I didn't realize how far apart we really live. I definitely really like him. I absolutely was so excited to see experiment. But our biggest challenge coming back from the honeymoon is the holidays, and we both have our own traditions with our own families.
Notice if you break down the word commutative, it just means back and forth. That's all it says here, which is you can add two numbers back and forth and still get the same result.
This situation is kind of a whole jumble. It's just all over the place.
So every year I go to my Italian grandmother's house, and she makes little seven dishes, and it's a big deal. You know, Italians have to sweet.
What's to say that? You know, you just spend all there and watch the kid open up the presents. You know, it's kind of important thing to me.
Because of the distance between us, and because Christmas is a big deal for both of our families, and we have our own traditions apart, you know, it definitely seems to add another level of stress about how we're going to make it work together.
It's the same for multiplication. We can multiply two numbers back and forth and still get the same result. Commutative.
Certain things I can't. You know, our efforts would really be appreciated today.
You know, we had no time, got married, now we quickly have to figure out where we're going to live, and how we're going to compromise, and, you know, it is a lot of work.
I don't want to take the joy out of your Christmas. I don't want the joy out of my Christmas. You know, I'd love to spend with you. Love to. And I'm going to try. I know you're going to try as well.
There you are.
The associative property of addition says that if you add a group of numbers, that you can group them how you want. For example, I can group the last two numbers together and add them, Or I can add the first two numbers together and I'll still get the same result.
I'm very affectionate. And I'm here.
The associative property of multiplication just says when you are multiplying a group of numbers, you can group the multiplication how you want. For example, you can multiply the first two numbers together, then multiply the last number. Or you can multiply the last two first and you still get the same result.
But this is not dating, like this is marriage. So I don't want to get in my own way. I know that boys can be very stupid sometimes, and I'm not sleeping right away, but I am going to ask you to really try to be as receptive as you can. And I will try to say things as they happen. But now you know when I show emotion like that, it's deep.
I don't want to upset her. I don't want to see her sad. I want to do the right thing, and I will do what needs to be done to make this right.
The distributive property says that if you have a number multiplied to a group of numbers added together, you can distribute the number to each number in the group and still get the same result.
For the wedding, he said that first things are trashy, and talked about like tattoo. That's trashy.
Nobody wants to call trashy, but I didn't call.
You're not my favorite person right now.
Why am I not your favorite person? I don't want to upset her. I don't want to see her sad. I want to do the right thing, and I will do what needs to be done to make this right.
We were going to dinner, and we were standing in front of the restaurant waiting to be seated. I had pictures on my phone, and I showed him my memorable piercing that I've taken out, for the wedding. He says that piercings are trashy, and he talked about like tattoo.
Here are examples that involve simplifying expressions by combining like terms.
You just don't say that to a
That's
person.
not what I said. I didn't say you. I said it looked nicer. That's exactly what I said. I said it looked nicer. I said I don't like other PCs. I think some people in certain situations have selective hearing, and they're not really listening 100% what the other person is saying. To me, I wasn't being offensive. I have complimented her thousands of times and told her how great she looks, and where does all that go?
Well, if you say it's trashy and it's something that I have on my body,
But I didn't say it was good on
you
you.
did not.
Yes, I did. There are a lot of ingredients in spouse. I said on you it looks nice, and other people it looks trashy, and it does look trashy on other people.
And then you said, hey, my tattoo is trashy. You have a whole box of tattoos.
Conversation I have later. I don't want to talk about it. It's done. It's already done. I swear. Oh my God. Don't bother me. Seriously, don't bother me.
Next time on Married at First Sight. We've done so much in a week. We met, got married, went on a honeymoon. It's really overwhelming. After knowing each other for just 1 week, the couples will spend the holidays together.
Merry Christmas.
Never thought a year ago that we made your gingerbread cookies with my life.
Tell me about the honeymoon, Ryan.
Isaac was a master of math.
Here are just some more practice problems to help review some of the topics we discussed.